Welcome back to the deep dive. Today we're looking at a piece of hardware that, well, it usually lives in the dark, humming away in a server rack,
Right.
but it's pretty much the lifeline for anyone managing a huge data center. We're talking about the NTI SERIMUX-CS-16 console serial port switch.
It is a mouthful of a name, isn't it?
hmm
But, if you look at the specs we have here, this thing is basically mission control for IT.
That's exactly the vibe I got. Because you picture a server farm, rows of servers, routers, all this telecom gear. It's just chaos.
Total chaos.
And the main problem the sources point to isn't just the sheer amount of hardware, it's how you actually talk to it.
Exactly. In a traditional setup, if a router goes offline, you might have to physically wheel a laptop over to the rack.
The old crash cart.
The crash cart, yeah. You plug in a console cable, you type away. That just doesn't scale.
Yeah.
This NTI unit, it consolidates all of that into one single hub.
It's like the master key for the whole building.
That's a good way to put it.
Now, looking through the documentation, one feature immediately jumped out at me because it seemed, well, oddly specific. The protection for Sun host computers.
Ah, yes. That's a fascinating bit of legacy engineering that is still incredibly critical.
Why is that?
Well, SUN systems and some other Unix-based hardware, they have this very specific vulnerability. If they get what's called a break signal over the serial line, they interpret it as a command to halt or even reboot.
And that break signal can happen by accident.
Right.
Like just from plugging a cable in or power cycling the switch itself.
Precisely. Imagine the nightmare. You're just trying to reset the switch to fix a tiny issue. The voltage on the line spikes for a second. The server reads it as a break, and boom.
Your mission-critical database is suddenly rebooting.
And it's all your fault. This switch has logic built in to just suppress that signal. It's like a safety catch on a gun, really.
That's a great analogy. It prevents friendly fire. Okay, so moving to the physical side. The model name says 16, but I see here it can control up to 32 devices.
Yeah, it's modular. You can daisy chain them. But the real insight here isn't just the port count. It's the translation ability.
Right, because in a real data center, you've got old gear and new gear all mixed together.
Exactly. They don't all speak the same language. One device might be running at, say, 9600 baud, and another is at 115.2K. This switch handles that. It buffers and negotiates, so you can have 32 devices with totally different speeds running at the same time.
And it uses standard CT5 cabling.
Which is a huge logistics win. I mean, compared to those thick proprietary serial cable,
Oh, yeah?
you can run CT5 up to 100 feet. It just cleans up that cable spaghetti in the back of the rack.
There was another feature I wanted to drill down on. The data buffering. The sources describe it almost like a black box on an airplane.
That's the perfect way to think about it. The switch has internal memory for each port, and it captures the last few kilobytes of data coming from the device's console.
So if a server has a kernel panic at 3 in the morning and locks up, the screen is usually just frozen, right? Or
Yeah.
blank.
Totally blank. But with this buffer, you can log in after the crash and basically replay the tape. You see the error codes that flashed across the screen right before it died.
So you have forensics. You're not just guessing.
You're not guessing. It's the difference between a 5-minute fix and a 5-hour investigation.
Which brings us to out-of-band access. The term comes up a lot here. Can we clarify why that's so important?
Sure. So in-band is when you access a server through the regular network, the same one your users are on.
Okay.
If that network goes down, you're locked out. You can't use the network to fix the network.
You're locked outside the house without a key.
Exactly. Out-of-band is a separate, dedicated service road. This switch gives you access completely independent of the main network. So even if the main highway is on fire, the fire trucks can still get in.
And to keep that road open, the switch itself has to be tough. I noticed it's a 1RU steel box with dual power supplies.
That redundancy is non-negotiable. If you lose one power circuit in the rack, you can't afford for your management tools to go dark too. This thing stays alive.
So pulling it all together, it's not a flashy device. There's no AI, no RGB lighting.
No, it's the workhorse. Ideally, you install it and you forget it even exists. But when things go wrong, it's the only tool that actually matters. It keeps uptime high and panic levels low.
It really highlights how much of our digital lives depend on these rugged, sort of invisible boxes. We worry about Wi-Fi speeds, but the internet really runs on RS-232 connections in a dark room.
It really does. And here's a thought to leave you with. As we move everything to the cloud, we forget about the physical hardware.
Right, it's just out there.
But the cloud is just someone else's computer. So how much of the modern web is actually relying on a single out-of-band serial switch like this one to prevent a total outage when the main software fails.
That is a sobering thought to end on. Thanks for listening to this deep dive.